Hi, hello, this is Jenny. So today's topic is data structures and algorithms. Okay, so in this topic, why we should study, if you have about this, if you have any doubt about this topic, I will clear you everything. Okay, so yeah, come on, let's go to this topic. So data structures means, for example, I'm running an organization, right? So running a small organization. So that organization, I made some website for the users convenience. Okay, so that website is user friendly one, so all the users, they can see my website and they can ask their queries to me directly. But how it will work? Front end design portion and back end, I'm going to use some databases. Okay, so the users details or data, it's going to store in the database. Okay, so here you can see, for example, so my company is Jenny Private Limited. Okay, so this is my website. In this website, I have users details. Okay, so the users who will see my information data, so they are going to enter their name, okay, phone number and address, okay, and their queries. Okay, so they will give their data. Data means information, details. Okay, so automatically the website is going to, okay, it's going to produce all the information, those who are viewing and those who are giving their details in my website. Okay, so I can see directly from my system. Okay, so this is my front end. So here you can see, this is my front end. Front end means front end designing portion. Okay, so design portion and back end. Okay, so back end means front end means designing portion. Okay, and back end means data base. Okay, so in this front end and back end, we are going to store data. Data means details, information. So in this data, how we can store, or in which methodology we can apply to store this details in my databases. Okay, so that is called data structures. Okay, so data structures means I'm going to solve, okay, small or big. Big means complex. Okay, big problem. Okay, so this is called data structures. So I'm going to solve the problem whether it may be small or big one. Here I'm going to apply algorithm. Okay, so algorithms means step by step rules. Okay, step by step procedure. For example, I'm going to study. I want to study a doctorate. So doctorate means easily I can't get it, right? So if I want to touch this doctorate means I should need what? I should need 0 level and then first standard, first to 8th standard and 9 to 12th standard. Then I need basic degree, 1 degree. Then I need masters. Okay, masters. And then I need philosophy, masters in philosophy. Then I should get doctorate, right? So if I want to get the doctorate, I should cross this cycles, okay, from 0 level to top level. So I should come up from low level to top level, okay. So in the same techniques we are going to apply in our algorithms, okay. So algorithms means step by step procedure, okay. First step you should write like this, and then second step you should move that data to the memory, and then third step we can move ascending order or descending order, okay. So here in this algorithm is used for to make a software, okay. So in this software it works, supports with the help of hardware, okay. So in this system means computer. So computer we are going to see software, hardware. Hardware means full and full physical wire, right? So physical wires, physical connection, and software means algorithms. That means programs. Collection of programs is called software. Collection of physical components is called hardware. So both hardware and software, combination of these two parts is going to produce a system. In this system we see lots of applications or websites, okay, applications and websites according to your business, okay. So whether I can do a medicine business or construction business or universities business or school business or government business, anything, okay. So you can take anything, each and every department has a unique applications, right? So all the applications is made by this algorithms. So algorithms is used for to make a software. So that software is works on that applications, okay. So in that applications is going to use for end users. So the end users can give their data, okay, data directly. That data is going to stored in the database, okay. So data we can store sequential, linear and non-linear. Two methodologies we can store. One is sequentially we can store, another one is random wise we can store. So if you want to store your data, or you can retrieve or you can take back your data, we should apply this methodologies or techniques in data structures or algorithms. So that is the benefit of this topic, data structures and algorithms, okay. So now let's come to this topic. Here you can see what is data structures. So data structures we can split in two parts. One is linear, another one is non-linear, that is order wise, non-order wise, right? So in this linear, we can derive 4 parts. That is, arrays concept we can apply, linked list concept we can apply, stack concept we can apply, and then queue concept we can apply. In this stack and queue, what is the difference? If you are asking this question to me, the answer is very simple. If you are using LIFO concept, okay, in stack methodology, if I use FIFO concept, that is queue methodology. Okay, so what is the difference between stack and queue? Means we can store this information here, you can see. So in this stack, I'm going to store like this, but queue we can store like this. So this is LIFO, this is FIFO technique. Okay, so LIFO means I'm going to use this value, store this value A, okay, B, C. Here directly I'm going to store A, B, C. Okay, so if I want to take this value C, means for storing stack value I should use this push function. Okay, I use this push function, okay, for store the value. If I take this value, I should use pop function. Pop means removing the element. So if right now I remove this element, okay, if I remove this, automatically your value is 2, A and B. The two values are in your stack or rack. Okay, so that time if I want to insert new value, again I want to insert new value, for example D, I should use this push function in that stack concept. In this queue concept, easily we can remove this value. That is, if I insert this A value, means immediately it will come out. But in this stack concept, if I want to remove this A value, means, or C value, means, we can remove one element, another element, and then last only I can get this answer. So that is last in, first out. If I insert the first value, it will stored in the last segment. Okay, for example here A, B, C, but right now I need this value. How can I take? First we should remove this B and then we should remove this C, right? Yes. So now I remove this element. So my value is down. Now I use this pop function. I can get this last element in first. So that is the concept of last in, first out. Okay, so I stored my data in the last rack or last memory, but I take first out. So my last data is going to come at first, but in this queue concept, my data A. So immediately I can get this data by using of this concept, queue concept. Okay, that is first in, first out. So if I insert data directly, I can get that data back directly. That is first in, first out concept. Here there is no queue. Okay, there is no queue, there is no latency, there is no what? There is no need extra time to get my data. So immediately I can get my data. That is the concept of queue. Okay, and next, so that both concepts we can use in this data structures lot. Okay, so stack means real-time example we can see when we are going from passport office. Okay, So we should follow these rules one by one. Okay. For example, 1 by 1 means all the people should standing or should follow their previous person, right? So one person first should go, then only other person then can go. Immediately or intermediate any other persons, they can't go intermediate, right? But in this queue concept there is no queue, there is no line. So if you go, you can meet the persons directly and you can get the data quickly. Okay, so that is the benefit of this queue concept. Okay, and next one is, if you don't follow this rules and regulations or sequential manner, means we can use this non-linear concept. Here you can see tree concept, graphs, tables and sets. Okay, so lots of organizations, they will use this graphs technology. Okay, here also I can give some example for your understanding. Mm, I'm running. Okay, I'm running an organization. So I have 160 or 170 branches all over the world. Okay. So I'm going to meet all the branch regions. I want to know about my profit and loss. Okay. For example, 5 years data I need. So I call the all branch regions. So all the branch regions, they are going to apply their data to me because I am the CEO of that company, right? Just imagine. For your understanding, I'm telling this concept. Okay. So that time the branch regions, they collecting all the data from their employees. Okay. So those who are working under their category. Okay. So that branch regions collect all the data from their assistants and they will make some presentations to produce me. Okay, so in that presentations I can see my company's profit and loss, right? So in which year my company is going to be a top, and which year my company has been gotten loss. I can see this two different variants. Okay, so differences by using of their presentation, right? So in this presentation they will use that trees concept or graphs concept because to analyze their data. Okay, so that time only I can view or analysis the company's data. Okay, so in this graph technology we can see, so they will produce this type of graphs. For example, this is your x-axis, this is your y-axis, right? So I'm going to see their presentation. So they will produce like this. For example, this year 2010. Okay, so and this year 2020, and this year 2025. So the branch region give their presentation to me. So I'm watching his presentation, so how he is performance and how he is explaining their data to me. Okay, so he explained in for 2010 you got this 20%, and 2020 we got a 10%. Okay, and 2025 we got 50% profit. So right now he explained that profit only. So as a CEO, I'm watching. Okay, so this is the company's profit. Okay, company's profit and loss. So next I'm putting some forward step. Okay, so next what is the process I should take in my organization to develop my career or to develop my business. Okay, so this is the presentation of graphs. Okay, so in this real time example we can apply like this methodology. So in this methodology, as a CEO, I can't go all the branches, I can't take each and every data for one by one. It's not possible. Okay, so just imagine it will take too much of time and too much of years to calculating everything. I need a partial output. Okay, so partial output means random output. So overall, okay, so overall 5 years output or 10 years output, I will ask that branch managers or branch regions. So they will produce this type of data. But each and every year, they should make some data. But as the head of position, I will ask each and everything. Okay, so I will ask random wise. That is non-linear technology I will apply in my organization. So that time I'm using this concepts. Okay, so graphs concept, trees concept, tables concept, and sets concept. Okay, next, in this data structures, if you are taking linear wise means we can apply arrays concept, stacks and queues concept, and searching technology. Okay, so if I take non-linear means we can apply trees, graphs, tables, and sets. Okay, so trees means we can see like this searching. Okay, but stack concept, queue concept means we can see this rack wise memory. So that means rack wise memory means we can store data in the sequential manner. Okay, so one by one, a b c d, 1 2 3 4. Okay, so if I don't use 1 2 3 4 or randomly I called 1 5 6 or 10 means we should apply this trees and graphs methodology. And searching, if I want to fetch the data from the year 2012, but right now it's running 2025 means how we can take by using of this searching and sorting techniques. Okay, in your data structures. Okay, so this is the benefits of your structures of data. Okay, and next, so this is the another example for your understanding. Okay, so this is the stack concept. Okay, so I used some data means this is your value. For example, in this methodology I should get all the details in ascending manner. Okay, I need all the data in ascending manner. Okay, ascending, descending, we know the difference. Okay, ascending means, yeah, small to big, descending means big to small. So now my data is descending order. That means there is no sequential, there is no order wise. So randomly scattered in that memory, but I should make all the data in a sequential manner. Okay, so that's the reason I'm going to apply this concept. So first pass. Okay, so here I'm going to move three transfers. So first transfer, I used this number first digit to second digit. That is means swap means I'm going to exchange this data. Okay, so data means value. Okay, for example, here you can see 7643. Okay, so first 7 is going to exchange 6. Okay, so 6 is going to come in the first position and 7 is going to second position. Okay, so the next step you can see this example. So 6 is first position and 7 is second position again. So I'm going to exchange this value. Okay, exchange this value means the same methodology. 7 is going to exchange the next position and 4 is going to come up next position. Okay, so you can see 6 4 7 and 7 again it's going to move another node or another stack. Okay, so here you can get 6 4 3 7. Okay, and second pass the same. First node is going to move second node and second node also move to third node and third node also you can get this answer. Okay, so in the third pass you can get this 3 4 7. Now you can see, is this ascending order, descending order? Yes, ascending order. Okay, 3 4 6 7, small to big. So now my data is very perfect in my memory. So easily the users, if they ask details, what is the data of my tree, so I can get this data tree from the memory. If someone asks give the data of 6, I can give that 6 to the users. Okay, so this is the benefit or usage of this stack concepts in data structures. Okay, next one is, this is your trees technology. Okay, So in this methodology also we can store data in the databases. Okay, so this is your first one is root. Okay, second one is they given some example parent. Root means our elders. We can imagine our elders. Okay, so in this elders we are coming from heredity. Okay, so next parents is coming. Okay, for example 3 persons 2 3 4 1 2 3 4. Okay, so this is your data. And next from the parent we can derive child, right? So in this child 6 and 7. Okay, so in this child they have some siblings. Okay, siblings means for example two child they have some siblings, for example 8 9 10 11. Okay, so these are the siblings. So like this we can store our data in the data structures. Okay, so here I'm using trees methodology to store my data. Okay, next this is the concept of stack. Okay, stack means I'm going to use two types of operations. Okay, so four types of operations are available, but we should see mainly two types of operations. What are they? First one is push operation. Okay, before inserting element any values in your memory means we should check the memory box, whether it should be empty or full. Okay, so now my data is E. This is my inserting element. So I'm going to check from bottom to top, because already bottom I have stored this as A value and then B, C, D. So next, where can I store this value? Yes, at the top only I can store this E value, right? So this is your top position. Here I can store this E value. So push means insert the value. Okay, so this is the example for stack operation in the linear methodology of data structures. Okay, next. So if I want to store informations at the top means I should check the memory is full or empty. Okay, so here you can check this calculation. So empty means you can get that value is true. Yeah, if your memory is right now empty, but your memory is full means it will show the false statement to you. Okay, so this is the operations of empty in stack. And next, this is the main operation of this stack. For example, I am here, my memory is searching, my memory is full empty. So empty means I given this value negative. Okay, so next I'm going to positive value. So stack 0, stack 1, stack 2, 3. That means 0, 1, 2, 3. Okay, so stack 0 I'm going to insert this 1 value, and stack 1 I'm going to store this 2 value, and stack 2 I'm going to store this 3 value, and stack 4 we can store this another value, new value, for example 4. Okay, so stack 2 I stored 3 value. Now I'm asking this value return stack 2. Return stack 2 means here the memory is your data. Your data is stored in memory stack 2. So the user asked return the stack value number 2. So in this number 2 your value is, your data is 3. Okay, so if I give this algorithm or program in my coding, so automatically the memory fetch the data from the stack 2, it produces the value number 3 to the user. Okay, so like this we are going to store all the information in our database. Okay, so this is the stack concept. Okay, so push means we are going to insert the values from bottom to top. Pop means we are going to remove this element, and peek means, okay, so return the element. Okay, so if I want to take that elements means we should use this return statement, return algorithm in your coding. Okay, then only I can get this stack 2 value is 3. For example, here I am putting stack 1. Stack 1 means what is the value? Stack 1 value is, this is your 0, 1, 2. Yeah, stack 1 value is 2. So you will get the answer is 2. Okay. Next one. So operations of stack: push operation, pop operation, pick operation, empty operation, and fill operation. Okay. So push means insert the values, pop means remove the value, pick means return the top of the value. So before that storing some values in your stack means we should check stack is empty or full. So that time we use this function or operation, empty operation or full operation. Okay. So this is the basic methodology or basic technology of data structures. So thank you so much. Bye, friends.